Let's keep recording again. But there we go. Hopefully now you can see though that we want to know when f of x is 5, right? Okay. Well, again, we're just solving an equation, right? We're trying to figure out what x is. Now, the idea again is we're given f of x here. We're given the output. And we want to now figure out when is x such that f of x is 5. Okay, well, again, we just solve an equation. So it's just basic algebra. You know, we subtract, as before, we subtract 9 from each side. Okay. Then we have -8 times x is -4, as you can see. And then, of course, you divide by -8. Right, so again, let me say it again. We have -8x plus 9 is 5. So we want to get x all alone. So we have plus 9 here. What do we do? Let's subtract 9 from each side. That gets rid of the 9. We have -8x is -4. Okay, now we divide by -8 because we get x all alone. You know, what you do to one side, you do to the other. So x has to be 4/8. The negatives cancel, which is a half. So when x is a half, f of that gives us 5. 5. That was fun. Okay. So that's with a formula. Okay. That's with the formula. Now, what I want to do next is this. So here, we saw already that with a formula and with a table, you can define a function. Now we can, and also really from the first example, we can define a function by writing out what it does in complete sentences, you know, with words and stuff. But now we're gonna see a graph. And here I wrote the definition of what a graph of a function is. Basically, if f is a function, every point, the graph is all the points of this form, where y is f of x. So the whole idea here is you're representing the inputs and outputs as ordered pairs in the plane. And the graph of the function is all the points of this form, or equivalently this form, or this. You know, your input is your x value, x coordinate. Your output is your y value, y coordinate. And here I'm just saying that the function is the graph is the collection of all points of this form. Again, that's just a definition. So for instance, you know, again, this could be a graph, for instance, right? This is all, for our function f, this is all the points of this form, where f is where this is the graph of f function, and the x comes from the x-axis. Actually, I should say this. X is input that lives in the x-axis. That's better. All the input values come from the x-axis. The y coordinates, right? Those are the outputs, the corresponding outputs. And that's what I'm trying to show you here. Okay. I know here it looks like B would be 4.5. I'm not saying it has to be, but I just wrote it out that way by coincidence. But that's just what a graph of a function is. You're looking at all points here. And you might be wondering, well, why would we even do that? Well, it's kind of like that old saying, a picture is worth 1,000 words. You can learn a lot, about a function from its graph. You can figure out what the range is, the domain. You know, those things may not be so obvious. If you're given, say, a formula for the function, you could determine, we'll see later, when the function is increasing, decreasing, things like that. You can learn a lot about a function from its graph. And you can even get input and output from the graph. I mean, maybe this is not the best example because I haven't really specified things. Well, actually, I shouldn't say that. This is good. But let's look at this example. Here, I have another function drawn, okay, as you can see. And I specified some points. So, for instance, 3, 2, that's on the graph, right? Okay. And again, let me just say how I plot that. You find 3 on the x-axis, okay? And then you're going to go up or down depending on the y-coordinate. The y-coordinate's positive, right? It's 2. So you would go up 2 points, 2 units, that is, which in this case is up here. But anyway, 3 is on the graph. That tells us f of 3 is 2. F of 3 is 2. So 3 is in the domain, and the function maps 3 to 2. That's what this is telling us. Okay. As another example, since 1, 2 is also on the graph, okay, that tells us 1 is in the domain, 2 is in the range, right? And f of 1 has to be 2. F of 1 has to be 2. So 2 values get mapped to 2. Again, it's still a function because each input gives you only 1 output. You know, at 1, you're only going to get back 2. 3, you only get back 2 as well. We have another one down here, right? F of 2 is going to give us 1, right? 2, 1 is on the graph. That's what that tells us. Good. So f of 2 is 1. Good. I didn't write this on the slide, but let me just say this also. Notice that the graph never passes through the horizontal axis or the x-axis. It never passes through here. That tells you no function value maps to 0. No function value maps to 0. So here, let me draw the pen. So if we had something like this, let's say, then here, whatever that point is, f of that would go to 0. Might be saying too much, but hopefully you understand. So that's what's happening here. It's just something that I just felt like saying it. Here, let me erase that. Okay, good. So it's just another example. Now here, so here's our second example. So let's say now we have this graph, okay? And let's say we want to know what f of 0 is. I mean, you could probably guess what it is from the point, but let me just show you though. F of 0, right? Well, here's 0. The graph is up. So we go up to the graph and we get to 3. So even though the point's here, I guess you can imagine if it wasn't there, you just look for 0 on the x-axis or the horizontal axis. And what you do is you're going to go up to the graph and you'll end up at 3. In other words, the point 0, 3 is on the graph. So f of 0 is 3. Okay, so we have that now. Okay, what about this one? Here's another one. What would f of 1 be? What's f of 1? Well, let's take a look. Well, if we look for 1 on the x-axis, f of 1 is over here, right? That's what we get. Now notice, since this is on the x-axis, meaning the graph is directly on it, that tells us this point here, if I can draw it, is 1, comma, 0. So f of 1 here is 0. Because again, the graph is on the x-axis. So the point doesn't go, you don't go up or down to get to the graph. You're on the x-axis. So f of 1 is 0. Same thing with f of 3. Right? F of, there it is. F of 3 here, right? That's also on the x-axis. So the y-coordinate is 0. And because of that, f of 3 is also equal to 0. Well, let me fix that. Eraser. Just want to write it in. So f of 3, that's good enough. F of 3 is also 0. So we get that. Okay, so that's an example. Okay, that's good. Oh, in fact, I do actually have it on the next slide. I forgot I had that. But f of 1 is 0, as I just said. So f of 1 is 0. Forgot I had this here. But as I just said, f of 1 is 0 because we're on the x-axis. F of 2, right? That's -1. And why is that? Well, again, you find 2 on the x-axis right here. Now, you want to go up or down. You want to go vertically to the graph. So in this case, we're going to go down 1 unit, right? So f of 2 is -1. And that's what we get. Right? So again, you find the x value on the x-axis, and you move vertically to the graph. So that's f of 2. Okay, good, good. All right. Let's got that here. Let me just ask this.